From collection and sorting to shredding, melting, and precision rolling, this is largest aluminum can recycling. You've never seen it before. Get ready for a journey through massive machines, molten metal, and cutting-edge industrial engineering, all in Factory Founder.
Keep them moving. Heavy low, watch your back. Push that bin forward. Got it, feeding them now.
At first light, before cities fully wake, the aluminum recycling process is already in motion. Across an immense industrial landscape, trucks line up in steady silence, carrying the remains of everyday life. Billions of discarded aluminum cans. What looks like waste is, in fact, one of the world's most valuable recyclable materials. Aluminum never truly disappears. It only changes form. This facility is one of the largest aluminum can recycling plants on Earth. Every hour, thousands of tons of material move through its systems. Every day, the equivalent of millions of cans are reborn. What you are about to witness is not just manufacturing. It is a closed-loop industrial ecosystem. As vehicles enter the facility, they roll onto massive industrial weighbridges. Every kilogram is measured, logged, and digitally linked to its source. Inside the receiving hall, scale becomes impossible to ignore. Steel columns tower overhead. Conveyors stretch deep into the building. Bridge cranes glide silently above rows of compacted aluminum. Bales are fed into automated breakers that loosen the compressed mass, allowing individual cans to separate and flow freely. Workers remove steel binding wires, sparks flashing briefly as metal meets metal. This is where bulk logistics ends and processing begins. The aluminum now enters the first sorting phase. Wide conveyors spread the material evenly. Vibrating feeder beds ensure consistent flow. Cameras scan continuously, analyzing shape, reflectivity, and density. Along the line, trained operators remove visible contaminants, plastic bottles, glass fragments, oversized debris. Their role is critical.
Keep the blue bottles in chute 1. Glass goes in 2. Okay, got it.
Automation is powerful, but human judgment still protects the system. Every contaminant removed here prevents damage further downstream. Sorting is not about speed alone. It is about protection. Now, automation takes over. High-speed optical sensors identify non-aluminum material in milliseconds. Bursts of compressed air eject unwanted items sideways into separate chutes. Thousands of cans per minute move through this corridor. Although aluminum is non-magnetic, steel contamination is always a risk. Powerful rotating drum magnets sit above the conveyors, pulling steel caps, wires, and fragments upward with violent force. Aluminum passes through, untouched below. Multiple magnetic stages ensure redundancy. The atmosphere changes as aluminum enters the shredding hall. Massive machines wait, anchored into concrete foundations, driven by motors the size of cars. Cans cascade into rotating cutting shafts. Teeth tear through the metal, flattening and ripping it apart in seconds. Noise is immense. Energy is concentrated, yet the process remains controlled. What emerges is not chaos, but consistency.
Main shredders engaged. Status is green. Initiate the feed rate increase, monitoring temper levels.
The airflow looks optimized. Maintain current throughput. Adjusting suction power. Verified. Speed is stable.
The magnetic separator is working efficiently. Noted, the yield looks good. Keep monitoring.
Shredded aluminum fragments flow forward, standardized and predictable. Shredded aluminum moves across high-speed conveyors under intense lighting. Air classifiers remove paint flakes, coatings, and lightweight residues. Dust extraction systems pull microparticles from the air. Samples are taken, tested, approved. The aluminum is now mechanically pure, and ready for heat. In the furnace hall, temperature becomes the dominant force. Shredded aluminum feeds into massive reverberatory furnaces. Inside, molten metal churns like liquid light. Oxides rise to the surface as slag and are removed. Alloy composition is measured and adjusted. Nothing is left to chance. When ready, the furnace tilts, and molten aluminum flows into insulated ladles. Solid waste has become raw material once again. Molten aluminum enters the casting hall. It flows into water-cooled molds, forming continuous slabs and ingots. Steam rises as metal solidifies instantly.
Parameters are holding.
Automated saws cut the material to precise lengths. Surfaces are inspected. Defects are ejected. This aluminum is no longer scrap. It is industrial-grade metal. The ingots move into the rolling mills. Under enormous pressure, thick slabs are flattened into long sheets. Each pass reduces thickness. Each sensor confirms precision. Hot rolling transitions into cold rolling. Surfaces become mirror smooth. Dimensions reach micrometer accuracy. This is where aluminum becomes usable.
Confirmed. System check complete.
Reject. Send it to reprocessing.
Acknowledged.
Begin new inspection.
Rolled aluminum enters finishing lines. It is cleaned, degreased, and chemically treated to improve corrosion resistance. Food-safe coatings are applied and cured in thermal ovens. Every surface is engineered not just to look perfect, but to perform safely in food and beverage applications. Sheets are slit into exact widths for can bodies and ends. High-speed cameras inspect every millimeter. Labels, barcodes, and digital records follow each coil. Approved material is wrapped, banded, and stored under climate control. Nothing leaves without proof. At the loading bays, coils move onto trucks and rail cars bound for can manufacturers around the world. Not all recycled aluminum returns to store shelves as beverage cans. Some of it is destined for a very different role. Not to hold liquid, but to carry power. Here, the same recycled aluminum, refined, purified, and engineered, enters a second life as electrical conductor, forming the backbone of modern power grids. This is where aluminum stops being packaging and becomes infrastructure. Inside the rod casting hall, molten aluminum flows once more, this time into continuous casting wheels designed specifically for electrical applications. The metal solidifies into a long, unbroken aluminum rod, cooled rapidly but evenly to preserve conductivity. Water sprays erupt into clouds of steam as temperature sensors track every degree of cooling. Too fast, and internal stress forms. Too slow, and grain structure suffers. Laser gauges confirm diameter and roundness in real time. Any deviation, no matter how small, triggers automatic correction. For finished power cables, the aluminum conductor enters extrusion lines. Molten polymer insulation flows around the moving conductor, forming protective layers that resist heat, moisture, and abrasion. Cooling baths solidify the insulation instantly. Spark testers verify insulation integrity at high voltage. The cable is no longer raw metal, it is a finished energy carrier. Finished aluminum cable is wound onto massive reels. Each reel is tested mechanically